How to record the normal cardiogram of the frog's heart? In the heart structure or the physiology of the mammalian heart, physiology of the mammalian heart and the human heart, structure is different, but the myocardial physiology is the same. Your journals, open page number 160. So first we will see about the normal cardiogram. For this, what is the procedure? First, what is the importance? We study the properties of the physiological properties of the cardiac tissue. Though structurally they are different. In mammalian heart, it is in human beings it is a 4-chamber heart. In the amphibian, it is a 3-chamber heart. Structure different, but the cardiac properties or the cardiac muscle properties are the same. And we are studying the cardiac muscle properties by recording the normal cardiogram and the various cardiac properties called cardiac properties 2, all or none law, or extrasystole. Like these properties, we are studying all the properties. So first we will see what is the normal cardiogram. So normal cardiogram is the recording of the mechanical activities of the heart. Normal cardiogram is the recording of the mechanical activity of the heart, and electrocardiogram is the recording the electrical activity of the heart. So this is the difference between the electrocardiogram and the cardiogram. Electrocardiogram is the recording the electrical activity. Cardiogram is the recording of the mechanical activity of the heart. So what is the procedure for recording the mechanical activity of the heart or the recording of the cardiogram? First, pitching of the frog is done. So what is the pitching of the frog? By inserting the needle at the head of the frog. By inserting the needle at the head of the frog, we make the frog unconscious. It is a myth. So by pitching the frog, that is inserting a pointed needle at the head of the frog, pit, that is make the frog unconscious without disturbing the brain of the frog. We are recording the cardiac activities of the frog's heart. So cardiac control center is at the brain, or the heart activity center is at the brain. So without disturbing the brain, we only destroying the spinal part of the frog's brain. So by pitching, that is inserting the needle at the head, rotate the needle and destroy the spinal cord. It is called as a pitching. So first step for the recording is the pitching of the frog's brain. Only the spinal cord is destroyed. After pitching, frog will become unconscious. Then mount the frog on the board, that is the myograph board, and we dissect the frogs. We dissect the heart of the frog. After dissecting the heart, we mount the heart with the instruments which are required for the recording of the amphibian grafts. So there is the heart fever, or there is a myograph board, kymograph, starling drums. So these are the instruments. First practical study of the instrument. All amphibian instruments will study that time. So mount the frog on the myograph board and mount the frog's heart. Position of the heart is the upside down. Upside down. If we see the structure of the frog's heart, it is a 3-chambered heart. It is a 3-chambered part. In human beings, there are 4 chambers, 2 atria and 2 ventricles, and in the frog there are the 3 chambers, 2 atria and 1 ventricle. This is the dorsal aspect of the heart of the frog. This is the sinus venosus, which is the pacemaker in the frog. So dissection of the frog, then mounting of the frog. While mounting, position of the heart is upside down, that is the ventricle is up, and atria or the atrium are the at down or the lower side. Like this, by we mount. How to mount? By piercing a bent pin at the tip of the ventricle. By piercing a bent pin at the tip of the ventricle without damaging the chamber of the ventricle. Without damaging. Through only the pericardium, only through the pericardium, we insert a bent pin at the tip of the ventricle and mount the heart upside down. So this is the position, because why it is upside down is important. When you are drawing the graph, you have to draw all the contractions, contraction of the sinus venosus, contraction of the atria, and contraction of the ventricle. So how to draw for that is important. When there is a systole, when there is diastole, what happens during the systole, what happens during the diastole. So mounting is a upside down, is remember, it is a most important. After mounting of the heart, it is connected with the cardiogram board with the help of the starting heart lever, and will record the graph. This is a recording drum. You see in the instrumental physiology, starting drum, and suppose here is the myograph board on which heart is mounted. Position of the heart is upside down. Piercing a pin at the tip of the ventricle without damaging the chamber. This is a connected with the starting heart lever. This is a connected with the starting heart lever. Recorded the graph with the help of the starting heart lever. And pin is inserted at the tip of the chamber only at the part of the pericardium. Don't pierce into the ventricular chamber, and record the movement. Now the sinus venosus is act as a pacemaker in the amphibian heart or in the frog heart. In human beings, which is the part of the sinus venosus act as a pacemaker? SA node. SA node is a pacemaker in the human beings, and sinus venosus is a pacemaker in the amphibian heart or in the frog's heart. So first we will record the normal cardiogram, or this mechanical activity of the heart. We only destroying the spinal cord, so heart function is there, or pumping of the heart is there. So pumping systole and diastole, we record the heart. What happens when there is a systole or the contraction? What happens about the liver of the starting liver? See here, when there is a contraction and when there is a systole, what happens for the liver? Liver comes down or go up? Down. So when there is a contraction, size of the heart will be reduced and liver will become down. So what record we will got here? Downstroke. So systole is a downstroke. Again, what happens when there is a diastole or the relaxation of the heart? What happens? Liver will goes up. So we got here the upstroke. That is a diastole. So systole is a downstroke. Contraction, diastole is the upstroke. That is the relaxation and recording of the heart. So how we get the effect here? This is the normal cardiogram of the frog heart. This is the drawing your notebooks. This is the normal cardiogram in your diagram. You have to draw first draft and then you have to draw in your journal. On the page number 160 there is space. So you can draw at the lower side. Now you draw in journal. This is a normal cardiogram. There are the three waves. We see 1, 2, 3. So this is a sinus rhythm. Yes, is the sinus rhythm. This is a sinus contraction of the sinus venosus. This is a sinus rhythm because of the contraction of the sinus venosus. This is an atrial rhythm, and this is a ventricular rhythm. ACV. We got the three waves in the normal cardiogram. If we record this graph on the fast speed, the waves are spread. Like this. The waves are spread on the fast speed, and we can visualize vein or observe vein. This is the sinus venosus, this is the atrial rhythm, and this is a ventricular rhythm. If we record this on the slow speed, there is a what happens because of the slow speed? There is a space near or where there is a two waves are at the less space, so we can't visualize the vein. this atrial contraction, ventricular contraction, or the sinus contraction. So this is on the normal speed, slow speed, and this is on the fast speed. So S is the sinus venosus contraction, A is the atrial contraction, B is the ventricular contraction. So this is the recording of the normal cardiogram. So in exam we keep this graph for the 3 marks. For the spotting, there are the 15 marks for the spotting or the graph and chart. What is the other here? Graph and charts. 5 graphs and charts are there. Each is for the 3 marks. In exam, we put this. This is for the 3 marks. So what are the questions? Identify the record. First question is identify the record. So what is your answer? This is the record of the normal cardiogram. This is the record of the normal cardiogram. Then what is the second? What does S, A and V indicate in the record B? What does S, A and V indicate in the record B? So what is S? Sinus rhythm. A, atrial rhythm, and V is a ventricular rhythm. Write down these questions also. For this graph, 3 marks. For the graph and chart, we put this chart, and each graph carries 3 marks. Then other questions are same record. Identify record A. That is a normal cardiogram. This is a normal speed, and this is on the fast speed. So there is a spreading of the waves. Second graph is of the fast speed. So there is a spreading of the waves. Second question is of what is pacemaker? What is pacemaker? So what is the pacemaker? What is pacemaker? Where there is a generation of the impulse, where there is a generation of the cardiac impulse, that part is called as the pacemaker. Which is pacemaker in the human heart? Second question, which is the pacemaker in the human heart? So SA node is the pacemaker in the human heart. So there are 3 questions for the 3 marks. Write down all these 3 questions. Identify record. What does S, A, V indicate in the record B? And third question is what is pacemaker? Which is the pacemaker in the human heart? 3 questions for the 3 marks. So this is the normal cardiogram. On the page number 160, this practical is there. There is a space. So you draw the same diagram on the page number 160. There is space. If there is no space, you have to draw on separate space and paste the space at that place. So next is the on the page number 160, effect of temperature on the frog's heart. Now we see the normal cardiogram. So what is the effect of the temperature of the normal cardiogram? For this practical, procedure is the same. Breathing of the frog, dissection of the frog, mounting of the frog's heart. Then recording of the normal cardiogram. First we record the normal cardiogram. And then what is next? Now we are studying the effect of the temperature on the frog's heart. So first, the normal saline, normal ringer solution of the 22 degrees Celsius, 27 degrees Celsius, normal room temperature, 27 degrees Celsius ringer solution we add on the frog's heart. Mounting of the frog is like this. With the help of the drop, we add 2 to 4 drops of the 27 degrees temperature of the ringer solution we are adding on the frog's heart here. First. And we record the normal cardiogram. We are studying the effect of temperature. So first normal effect we have to study. So by adding the normal ringer solution, we record the normal cardiogram. We get the waves like this: sinus, atrial, and ventricular. This is the normal cardiogram. Then warm ringer solution. Warm, not hot. Warm ringer solution, that is the 39 degrees centigrade. Warm ringer solution, 39 degrees centigrade solution we add on the frog's heart, and we record the cardiogram, or we record the activity of the frog's heart. What happens when we add the warm ringer solution? What will happen? Any change in there in the recording or no? No change. What change will be there? What happens? Because of the warm ringer solution, any change will be after there or no? Graph remains same. What change? Heartbeat increase. Why? We pouring the warm ringer on the frog's heart, which increase the activity of the sinus venous. It increase the pacemaker activity. Warm ringer solution will increase the pacemaker activity. So what happens there? Increases the pacemaker activity. What happens with the graph, with the warm ringer solution? Increase in the heart rate or decrease in the heart rate? Increase in the heart rate. What is about the force of the contraction? Increase. Why? Okay, because of increase in the pacemaker activity, heart rate will be increased. Why force of the contraction will be increased? Suppose this is the normal force of the contraction. I have to draw all three graphs here. So suppose this is a normal. So this is the height of contraction. What happens after adding a warm ringer solution? Height of contraction is increased. Amplitude of the contraction is increased. It is called as a force of contraction will increase. Heart rate will be increased. The distance between two beats will be reduced. Distance between two beats will be reduced. So heart rate is increases. Force of the contraction is increases when we pour the warm solution on the frog's heart. Heart rate increases because increase the pacemaker activity of the sinus venous or increase the activity of the pacemaker, so heart rate is increases. Why force of the contraction will be increases? Increase, yes. Enzymatic activity is increased, but before that, what happens? Increase myocardial activity, increase myocardial tissue activity. So increase the force of contraction. Why myocardial activity is increased? There increase the enzymatic activity. Because of increasing the temperature, there increase the enzymatic activity, decrease the viscosity. Decrease the viscosity and increase the enzymatic activity. This occurs because of the increase the myocardial contractility or increase the myocardial activity. So force of the contraction is increases. This is the effect of the warm ringer solution. Again, and I am telling this is a warm ringer solution up to the 39 degrees centigrade, not hot. We are not using here the solution more than the 40 degrees centigrade. We are not using the solution more than 40 degrees centigrade. What happens if we use the hot ringer? There is a heat trigger. There is a heat trigger. What is the heat trigger? This is also my question. Heat trigger. Now this is the effect of temperature. On normal cardiograph. So what is heat trigger? If we use the hot, there is a contraction. Muscle goes into the sustained state of contraction. It is called as the heat trigger. Where you listen this word? Rigor mortis. What happens in the rigor mortis? What is rigor mortis first? After that, what happens there? Because decrease the ATP activity, decrease the enzymatic activity, decrease in the temperature, what happens there? There is the muscles goes into the contracted state. It is called as the rigor mortis. Same like here is the heat trigger. That is, if we use the hot ringer solution, there is a denaturation of the muscle proteins and muscle goes into the sustained state of the contraction. It is called as the heat trigger. So avoid the use of the the temperature solution which is of the more than 40 degrees Celsius. So this is the effect of the one ringer solution on the normal cardiogram. Increase in the height of contraction and the increase in the rate of contraction. That is amplitude. Force of contraction will be increased and the heart rate will be increased. This is the effect of the normal warm ringer. Then we use the cold ringer of the 27 degrees centigrade. Effect of now we will see the effect of the cold ringer solution. For the cold ringer solution, again wash the effect of the warm ringer solution, pour some normal saline, that is a 27 degrees centigrade, record some normal bits by pouring the normal. So this is again recording of the normal cardiogram by pouring the here normal ringer solution, that is the 27 degrees. This is again normal cardiogram. After recording 2 to 3 bits of the normal cardiogram, we pour the cold ringer of the 22 degrees centigrade and record the graph. What happens after pouring the cold ringer solution? Force of contraction will be reduced and heart rate will be reduced. Why? Again, why this will happen? Rate will be increased, force of contraction will be decreased, both decrease, heart rate decrease, force of contraction decrease. Why? Pacemaker activity, inhibition of the pacemaker activity, inhibition of the sinus stenosis or inhibition of the pacemaker activity, so heart rate will be decreased. What happens for the force of contraction? Decrease. Why? Why force of contraction will decrease? Myocardial activity also decrease. Myocardial activity also decrease, so there is a force of contraction will be decreased. So after pouring of the normal ringer solution, we draw the graph. Comparison. For the comparison, you have to draw the normal cardiogram and then you draw the effect of the cold ringer solution. Force of contraction will be reduced and the rate will be, heart rate will be reduced. And this occurs because by pouring the cold ringer solution on the heart, we inhibit the activity of the pacemaker. So there is a heart rate will be decreased and there is also decrease the activity of the myocardium. So force of contraction will be decreased. If you draw the graph, I will draw the graph all both, which you have to draw in your journal. First normal cardiogram. And then on fast speed or slow speed and fast speed, both. You have to draw both in your journal. And this is a sinus stenosis activity, this is atrial and this is a ventricular. This is sinus stenosis, this is a ventricular atrial and this is a ventricular. Like this, you have to draw normal cardiogram in your journal. If now you have journal, directly draw in journal on the page number 160. So this is normal cardiogram. Then we will draw the graph of the effect of temperature on the normal cardiogram. For this also, first you have to draw the normal 2 to 3 bits. Then volume of the warm ringer solution, record the activity. So this is a normal. This is warm ringer solution. Increase force of contraction, increase rate of contraction. Again, what are the effect of the warm ringer for normal ringer solution? Record normal cardiogram. This is normal cardiogram. Again, for cold solution and record the graph. This is volume. So, internal draw two graphs. On page number 160, normal cardiogram, and on page number 161, effect of temperature. In front of that graph, you can draw here on the page number 161. Here, you can draw here. Effect of temperature. Normal, like this also, otherwise like this. Normal cardiogram, warm ringer, cold ringer. Normal cardiogram, warm ringer. Normal cardiogram, cold ringer. One above, one down. So, what are the questions for this effect of temperature? Again, this is a graph for the 3 marks. Identify the graph. First question is for this graph. Identify the graph. Write down the question. Identify the graph. Second, what is the effect of increased temperature of the frog's heart? Identify the graph. What is the effect of increased temperature on the frog's heart? Third question, what is the effect of decreased temperature on the frog's heart? Each question for the 1 mark. So 3 questions should be there. What is the effect of increased temperature? What is the effect of decreased temperature? अक्षय हाथ फैन लगाओगे? नहीं लगा सकते क्या? 3 questions. May we ask what is heat trigger in Viva? They may ask what is a heat trigger. So, if we increase the temperature of the ringer solution more than the 40, there is a denaturation of the natural proteins and muscle goes into the sustained state of contraction. It is called as a heat trigger. What is the cause for increase the effect or increase the force of contraction or increase the rate, increase in the enzymatic activity and decrease the viscosity for the warm ringer. For cold ringer, decrease enzymatic activity and increase viscosity. So these are the effects. So we finish your 2 practicals. One is the normal cardiogram and second one is the effect of temperature on the frog's heart. 2 practicals. Page number 160 and page number 161. Draw. We have time to take 3 minutes. Draw the diagrams. Draw. In general. What is the difference between the human heart and amphibian heart? Human heart 4 chambers, amphibian heart 3 chambers. Okay. Any other? Hmm? Human heart. Next. Okay. Pacemaker. Sinus stenosis is pacemaker in amphibian. SNO is pacemaker in the human. Any other? Special conducting system in the human heart. There is no special conducting system in the amphibian. Human heart highly sensitive changes in the pH, oxygen content, and blood. Frog's heart withstand changes in the pH, oxygen content, and the blood. So we use the heart outside the body of the frog. For the recording of these various activities or the properties of the heart, we can record because it withstands without there is changes in the pH or there is changes in the oxygen content in the blood. In human heart, coronary circulation is present. In frog's heart, coronary circulation is absent. 6 differences are there on page number 159. Then also they ask why frogs are preferred for experimental study. Frog is a cold-blooded animal, therefore it can withstand the changes in temperature, pH, oxygen content of blood. At the cellular level, the physiology is same as that of the human. Therefore, results obtained in the frog can be extrapolated. It is easily available, cheap, harmless, and easy to handle. We can prefer the frog heart for the experimental study. In your journal, they show in the diagrams on the page number 160 or on the page number 161. And written graphs are there. They are mirror image, exactly opposite to printed. See, on the right side there is a printed black color and the other. And this image is exactly opposite of the handwritten image because this is the mirror image. So you have to follow this because if we practically mount the frog heart and record the graph, we will get the record times like these 3 waves. On this side, opposite to this. So record like this or draw like this only. Because in last days in MHS journal, the record is like this. This is MHS journal, last, old. So you have to draw like this only. And why? There is a systole is a upstroke and diastole is a downstroke. What? This is upside down. We mount the heart upside down. So we got contraction, that is systole is upside and diastole, relaxation is a downstroke. Anything else? How many people have joined there? 117. 117. Now, how many students are there on hostel? 80. 80. 18. Only 18. And 7 are here. 11 are there. They are also going. Very well. Akshay, some में something. Yes. From next topic. आता क्लियर नेचर जर्नल मध्येच करा ना तुमच्या नंतर कसं पास सब क्या करते हैं इस लेक्चर्स का क्या है ते काय करायचं सगळ्या डिपार्टमेंटने मिळून ठरवलं पाहिजे. कम्युनिटीचे लेक्चर्स होतात. आप लोग नहीं कहना चाहिए उन बच्चों को आप लोग नहीं